Hello students, we are going to study the chapter metals and non-metals. Okay. So before coming to metals and non-metals, let us understand from where these words have originated. Okay. So matter, what is matter? It is anything which occupies space and has got mass. And this matter is classified into three. Okay. And what are that? That are elements, compounds, and mixture. Okay. So now coming to, we are now settled with these elements. Okay, we are seeing these elements. These elements, when we see, okay, they exist in the nature in the form of metals, metalloids, and non-metals. Okay. So, this matter, the matter is anything which occupies space and has got mass, composed of tiny particles, atoms, which is basically the elements, which forms the elements, because this is the purest form in which this matter can exist. Okay, and it can't be simplified. Okay, so these elements are exist or classified as metals, metalloids, and non-metals. Now, coming to metals, okay, what are metals? When I say iron, okay, something comes in your brain that yes, it is hard. It is hard. Is it malleable? If you hit it with the hammer, can it be drawn? Okay, can it be made flat? Okay, yes, it can be, isn't it? Can wires of iron can be made? Yes, it can be. So it is ductile also. Okay. If you hit it, can you hear a tinkling sound? Yes, you can hear. So it is sonorous. Okay. It can conduct electricity. So what are the basic properties of these metals? Okay. When we say about this metals properties, okay, so we can say first property that yes, it is very hard. Metals are hard in nature, okay, and it is malleable. It is malleable, okay. Now, it is ductile. Okay, it can conduct electricity. Okay, good conductor of electricity. Okay, good conductor of electricity. Now, any other points? Yes, we can say that yes, they have color. Okay, they have what? Color, and the color can be dark brown, okay, or you can say dark red, okay, basically. But it can exist in other colors also. Okay, so let us study these points, okay, one by one. Okay, you can say that it is lustrous. Okay, and we can also say that yes, it is sonorous in nature. So when I say lustrous, sonorous, lustrous, shiny in nature, sonorous, okay, produces the tinkling sound. One by one, let us see the properties. Metals are hard. Yes, I said right now with the example of iron. You can take copper also. Some examples also I am saying to you right now. Okay, it can be iron. Okay, iron symbol Fe. Okay, copper. It can be aluminium. Okay, and so on. Even sodium, potassium, all are metals in nature. But yes, the properties will be seeing that yes, there will be some exceptions. Okay. Like if we are saying that they are hard in nature, when we see iron, when we see copper, okay, when we feel it, yes, it is hard, it is too hard. But when we talk about sodium and potassium, okay, they are not hard, they are soft in nature. So we can write, yes, all the metals are hard in nature, yes, exception you can write of the common elements like sodium, potassium, okay, these are soft in nature and we cut with the knife, okay. Now, here they are malleable in nature, yes, they can be drawn into sheets when you hammer it. Okay, so if we talk about iron, if we talk about copper, yes, aluminium, when I see you have seen the aluminium foil, you wrap your food with that, isn't it? Because that is so thin in nature. So they are malleable in nature because they can be drawn into long sheets, okay? And here, yes, they are ductile in nature. Ductile means what? That it can be drawn into wires, okay? See, when we talk about this gold, the wires can be too long, okay, because they are too ductile in nature. Even iron, copper, iron, aluminium, there it can be also drawn into wires, okay. Now they are good conductor of electricity. Yes, they have actually free electrons in them. As the result, they are good conductor of electricity, okay. Now, color, when we talk about, when we see copper, when we see aluminium, when we see iron, yes, it has a characteristic color, okay. Lustrous also, they are shiny in nature, okay. And yes, they produces the tingling sound. And when we talk about the metals, okay, metals mainly exist in the form of what? Solid form, okay. It exists in solid form, okay. Yes, exception will be there of mercury, okay, which exists in the form of what? Liquid form, okay. So here metals have these properties, okay. So when we talk about this non-metals beta, okay, will they have the same properties like non-metals? No. Some example of the non-metals we can take carbon, okay, carbon daily, okay, we can take oxygen, okay, we can take bromine, okay, any other, these all are what? Nitrogen, these all are what? They are non-metals. They are non-metals. Why they are non-metals? Because they have some characteristics of, some specific characteristics, like when we are seeing these metals, okay, they are hard in nature. Are these non-metals also hard in nature? Okay, no, they are brittle in nature. Okay, it means when you just try to break it, it breaks. Okay, so it is brittle in nature. You hammer it, it will break. Okay, now are they malleable? They are non-malleable. Okay, they can't be drawn into sheets. Not malleable. Okay, now when we talk about ductility, can they be drawn into wires? No, they can't be drawn into wires, okay. So they are non-ductile. Now, are they good conductor of electricity? They are not good conductor of electricity. They don't have any free electrons, okay. But yes, there is an exception of graphite, okay. So they are not good conductor of, bad conductor, basically we can write bad conductor of electricity. Okay, exception we can write of graphite. Now, next, if we are seeing that yes, they are having color metals, we have said, do these non-metals have? No. Okay, no, they are not so colored in nature. Okay, non-colored we can say. Okay, now, are they lustrous? They are not lustrous in nature. But here also we will be seeing some exception, okay, that is of iodine. Okay, iodine is lustrous in nature. Even diamond you can say, isn't it? Diamond is also lustrous, okay. Now, next, that yes, Do they exist only in the solid form? No. They exist in all the forms. That is the solid, liquid and the gaseous form. Okay. When we talk about solid, take the example of carbon. Okay. And when we talk about liquid, take the example of bromine. When we talk about gases, okay, oxygen, nitrogen, anything you can take. Okay, so these are the basic things, basic characteristic feature of metals and non-metals. So what are these metalloids then? Okay, these have both the characteristics of metals as well as the non-metals. Okay, so its property will be intermediate between the metals and the non-metals. Okay, some examples of metalloids, okay, like germanium, okay, silicon, these all are what? Metalloids, and they have the properties of metals as well as non-metals. So we have studied about the physical properties of metals and non-metals. Now we are going to study about the chemical properties of metals and non-metals. Okay, so before starting this chemical properties of metals and non-metals, one thing I want to say to you all about the reactivity series. So what is this reactivity series? This says that how much reactive element it, how fast the reaction will take place with that specific element. So if we are talking about here the reactivity series, we can see that yes, the reactivity goes on decreasing from when we go from up to down. So if we are talking about sodium and potassium, which is more reactive, potassium will be more reactive, then sodium, then calcium, then magnesium, then aluminum, then zinc, then iron, then tin, then lead, then hydrogen, then copper, then mercury, silver, and then gold. Okay, so when we are seeing about the chemical properties, okay, so chemical properties, first let us see the reaction with oxygen, or reaction with oxygen or air, you can write, okay, oxygen or air, okay, here. When we are talking about air, it means air is consisting of all the gases, nitrogen, oxygen, hydrogen, other gases also, okay, but basically most of the elements react with oxygen, okay, and they form certain compounds, okay. So reaction with oxygen, when we are seeing, or reaction with air, we can take the example of this iron, okay. Iron, if we leave it as it is, okay, in the moist atmosphere, okay, it means the air consisting of water vapors in it, okay. What happens? We see some brown flaky substance after some time. Now let us see how iron reacts with the air, okay. Iron, Fe is the symbol of iron, okay, plus oxygen which is present in the air itself, okay, plus H2O. This reaction you might remember, you have studied earlier also, okay. The rusting, it forms rust, okay. What is rusting of iron? Formation of what? Iron oxide in the presence of oxygen and water, isn't it? So here what will be formed? Fe2O3, that is what? Ferric oxide plus hydrogen will be released out, okay. This is what? Iron oxide and hydrogen will be released out. Now if we take this iron is a metal, it is forming what? Basically oxide, okay, when it reacts with oxygen. Now if we are seeing about magnesium, magnesium plus O2, okay, gives what? MgO. This is what? Magnesium oxide, okay. So here we are seeing these metals, they react with the oxygen present in the air, thereby forming their oxides, okay. Now if we talk about this copper, okay, will it also form oxide, okay. So here let us see it, okay. This copper Cu, it is, okay, it reacts with what? CO2 plus O2 plus H2O. This CO2 is also present in the air, oxygen also present in the air, water vapors also present in the air. So reaction with air, when we are seeing with copper, it takes carbon dioxide, reacts with carbon dioxide also, thereby you will be seeing that it forms what? copper hydroxide, okay, plus copper carbonate, okay. This is copper hydroxide, and copper carbonate. This, how can you analyze this? Like if we are seeing about this iron, okay, this iron reacts with the oxygen of the air and yes, water vapor is present, thereby forming the iron oxide, and this you can see by the brown flakes or the reddish brown flakes on the iron tools. Okay, now like magnesium, what happens? Magnesium is a silver, it is found in the form of ribbon, okay, and it is silver in color, okay, and when it reacts with this oxygen, okay, of the air, okay, and basically it forms what? Iron oxide, and that you will be seeing that it is not lustrous in nature. Here you will be seeing that yes, the color has become whitish gray in color, okay. Now copper, you know the color of the copper, okay, but when it reacts with carbon dioxide, oxygen and this water, okay, water, it reacts with water, okay, forming the copper hydroxide, okay, and with the carbon dioxide reacting to form copper carbonate, and so we get the product copper hydroxide and copper carbonate. And here we are seeing that yes, basically all the color and everything has been changed. Here you will be seeing this copper utensils, okay, when it is left in air, okay, for a number of days, you will be seeing some greenish coating over there, and that is due to the formation of this copper carbonate and copper hydroxide, as this copper has been left in the air and it has reacted with carbon dioxide, oxygen and water, which is present in the air. Water is in the form of water vapors. Now, if we take this iron oxide, okay, and we add some amount of water in it, okay, and then we bring a red litmus paper over there, we'll be seeing that it changes blue in color. Why? Because this is indicating that these oxides are what? Basic in nature. Whether you have taken iron oxide, whether you have taken magnesium oxide, whether you have taken copper hydroxide, okay, or these all, whatever you have taken, all the oxides of metal, they will turn red litmus paper blue, because these all oxides are basic in nature, and this litmus paper indicates that yes, they are basic in nature, as red litmus paper changes to blue in color. Okay, now let us see the reaction with the non-metals. Come on, let us take sulfur. ठीक है, सल्फर को हमने लिया एक defragmenting spoon में, okay. The defragmenting spoon is in this manner. If you don't have, you can take a cap, attach a string to it, okay. And now this, what you are going to do, keep it in a container, okay. And in this spoon you are keeping what? Sulfur. क्या रख रहे हो आप? Sulfur, okay, and you are just burning this sulfur, heating it, okay, and here it will be producing what? Sulfur dioxide, SO2, sulfur dioxide, okay. Now here take the red litmus paper and keep it inside it, okay, and yes, you will be adding some amount of water, or you dip the litmus paper in water, okay, and then you bring it near it. You are bringing the red litmus paper, ठीक है. जब आपने red लाया litmus paper, you will not see any change in the this moist red litmus paper. Now bring blue litmus paper, but moisten it, okay, and you will be seeing that it is turning what? Red in color. So this is indicating what? That this sulfur dioxide is what? Acidic in nature. So when we talk about the non-metals, they are what? Their oxides are acidic in nature. So here let us write the reaction also. ठीक है, तो ये क्या हुआ हमारा? Sulfur reacting with oxygen, okay, forming what? Sulfur dioxide. ठीक है, अब sulfur dioxide plus water, okay, it will form what? H2 SO3. What is this H2SO3? ये हमारा सल्फरस एसिड है. Okay. What is this SO2? Sulfur dioxide. Okay. So, when we talk about sulfur dioxide, this sulfur dioxide I said to you with the litmus paper indicating that it is acidic in nature. With the reaction also you have seen that is sulfur dioxide. When we add water to it, it forms what? Sulfurous acid, thereby saying that it is what? Acidic in nature. So metallic oxides when we are seeing, okay, they are basic in nature. When we talk about the non-metallic, okay, they are acidic in nature. Now let us see the reaction of these metals and non-metals with what? Water. Okay, so reaction with water. So see, listen beta. These metals, they react with water to form what? Hydroxides and oxides. Okay. So if we are talking about sodium, okay, plus water, it forms what? NaOH. Okay. It means what? Sodium hydroxide. What is this? Sodium hydroxide. Okay. And plus what will be released out? Hydrogen will be released. But this reaction will be very, very vigorous. Why? We are seeing in the reactivity series that yes, this sodium is a very reactive element. It reacts with cold water and naturally forms what? It's hydroxide. This is what? Sodium hydroxide. Okay. Now, when we talk about potassium, potassium will also form what? KOH, that is potassium hydroxide plus hydrogen will be released. You are seeing all those elements which are coming above hydrogen in the reactivity series. Okay, they are going to react with this water and they are going to release out what? Hydrogen gas. If we talk about magnesium, okay, magnesium का symbol होता है Mg. ठीक है, तो Mg ने react किया हमारा water के साथ. Okay, this water will, but it will not react with the cool water. It will, we have to use hot water. Why? Because here we are seeing that yes, it is coming in the reactivity series. It is showing that it is not as reactive as that this sodium, potassium and all. Okay, so you'll be using hot water over here. Okay, so if you are using hot water, it will be forming what? Magnesium hydroxide, MgOH whole twice. Okay, this is magnesium hydroxide and yes, hydrogen will be released out. Okay, now, but if you are taking this magnesium, taking this water in the steam form, ठीक है, steam form में लिया, इसमें भी आपको क्या मिलेगा? What you will be getting? Magnesium oxide plus hydrogen will be released. So it depends. Okay, and here on what does it depend? It depends upon the reactivity series. Okay, if it is very, very reactive in nature, it will react vigorously, and we are seeing that yes, this hydrogen is being released. With this, heat is also released. Okay, the more the reactive element is, the more amount of heat will be released out. This sodium, this is why, as sodium is very, very reactive in nature, okay, this, it catches fire very easily if it is left as it is. So here sodium is stored in what? Kerosene oil. Okay, otherwise reaction is vigorous and it will burn. Okay, so here this sodium, potassium, these are very, very reactive elements. Okay, all these metals we are seeing that yes, it is reacting with water and thereby giving oxides or hydroxide. And yes, if that metal comes above hydrogen in the reactivity series, with the reaction of water, it gives out hydrogen gas. Okay, and more the reactive the element is, the more exothermic or more heat will be evolved. Okay. Now, when we talk about this non-metals, do they react with water? No, they don't react with water. This is the reason why non-metals are stored in water, while metals, when we talk about sodium, it is stored in kerosene oil. Here you can see simple many number experiments are done, and it looks also very beautiful, like sodium. Okay, if you put a bit of sodium, okay, taking a container, okay, of glass, okay, and keep only a bit of sodium in that, okay, and then drop of water, okay, a drop or 2 or 3 drops of water, you'll be seeing that it is glowing inside. Why? Because it catches fire very easily. On water also, if you drop sodium, stream of water is there, and you drop a bit of sodium on that, or a small length of sodium on that, okay, you will be seeing that it is catching fire. Okay, so it all depends upon the reactivity. As sodium is very reactive, we see the experiments, it yes produces tremendous amount of heat. And when we are talking about the non-metals, no reaction with water. Okay, they are non-reactive, though they are very reactive. When we have seen that yes, they were reactive when they were reacting with the air, but water not reactive, and this is the reason number of non-metals are stored in water. Now let us see the reaction with acids. Okay, reaction with acids. So these metals, okay, they react with the acids to form the metal salt, okay, and hydrogen gas is given out. Like if we are seeing example like zinc, if we have taken, okay, and we have taken sulfuric acid, H2SO4, dilute sulfuric acid, okay, we get ZnSO4 plus H2 is released out. Okay. Likewise, if you take any of the metals which are reactive, then okay, and comes in the reactivity series, okay, above hydrogen, it will give out hydrogen gas. And how will you identify this hydrogen gas? Okay, if you bring a splinter, burning splinter near the mouth, okay, in which the reaction is taking place. For example, you have taken a test tube, okay, and you have added H2SO4, that is sulfuric acid, okay. H2SO4 is sulfuric acid, okay, and in this you have added zinc to it, okay. You'll be seeing the reaction is taking place, okay, and if you bring a burning splinter near the mouth, okay, of this experiment, okay, it will burn with a pop sound. Why? Because this is saying that yes, hydrogen gas is being released, because hydrogen gas has got this characteristic feature that yes, when we bring a burning splinter near it, it burns off with a pop sound. Okay, so this is about the metals reacting with the dilute acids, okay, forming the metal salt, and hydrogen gas is released. And yes, mind it beta, that yes, this hydrogen gas will be released only by those elements which are coming above in the reactivity series. And above what? Above hydrogen. Okay, if it is below, like if we take copper, okay, and we take this H2SO4, okay, we will not get hydrogen gas because it is less reactive than hydrogen. Okay, now when we are talking about the non-metals, okay, so what about these non-metals? Do they react with these acids? No, they don't react. Okay, but when we are talking about the reaction with the base, okay, so we have studied about the acid. Now reaction with base, okay. Okay, so when we are talking about the metals, okay, not all the metals, but yes, aluminum and zinc, they do react with bases. Like if we take the example of aluminum, okay, they do react with this sodium hydroxide. Sodium hydroxide is NaOH. Okay, ये इसके साथ react करता है, and it gives what? Na2Al2O4. Okay, so you are seeing here, and yes, it also gives out the hydrogen gas. Okay, so here we are saying that yes, a do reacts with the base to form the corresponding salts, and a hydrogen gas is released out, and zinc also do reacts. Okay, but what about the non-metals? Okay, non-metals also reacts with the base. Okay, as you all know that yes, non-metals, they form acidic oxides. We have earlier studied it. So they react with the base, but the reaction with the base of these non-metals, okay, they form complex substances. Now let us study about some displacement reactions. Okay, displacement reactions. So what are these displacement reactions? Displacement means what? Just changing the place, interchanging. Okay, like in this, for example, we know about the reactivity series. Okay, we know that yes, the more reactive element, it will displace the less reactive element. For example, if we have taken, what we have taken, copper sulfate. ठीक है, copper sulfate लिया, solution लिया उसका, क्या लिया, solution, and we have added what? We have added zinc to it. ठीक है, zinc डाल दिया, तो हमारा बन गया क्या, zinc sulfate. Okay, plus copper is released. Okay, so here when we have taken this copper sulfate, it was blue in color. ठीक है, लेकिन zinc sulfate जब बना तो ये colorless हो गया, it became colorless. Okay, so here zinc has displaced copper. Zinc is more reactive in nature. It is displacing copper from the copper sulfate solution. Okay, and thereby forming what? Zinc sulfate. So in the displacement reaction, the more reactive element displaces the less reactive element from the solution. Okay, so this is why, and if suppose if we have taken ZnSO4, ठीक है, हमने क्या लिया, ZnSO4, okay, and we have added iron to it, do we see any reaction? Can this iron displace this zinc? See the reactivity series, zinc is coming above iron, so naturally we will not see any reaction, no reaction. Why? Because this iron is more reactive than this iron is less reactive than zinc, and as the result this iron is not able to displace zinc from the solution. Okay, if we have taken FeSO4 and we have added zinc to it, अब क्या होगा बेटा? Here will there be reaction? Yes, there will be reaction. If we have taken CuSO4 and we have added iron to it, will there be reaction? Yes, there will be reaction. Here zinc sulfate will be formed and iron will be released out. ZnSO4, okay, plus Fe. Here CuSO4 है, तो आपका क्या मिल जाएगा? FeSO4 plus Cu. Okay, so in this iron sulfate is formed, zinc sulfate is formed, but yes, here when we had taken zinc sulfate and iron, no reaction was there. Okay, if we are taking iron sulfate and copper, then also there will be no reaction. But yes, if we have taken zinc, zinc is more reactive, naturally it will displace this iron. So these are about the displacement reactions, in which yes, the reactivity series again is playing a important role. Okay, now let us study about the uses of metals and non-metals. Okay, coming to the metals, when we are saying metals, copper, iron, aluminum, all you are seeing utensils are made. Okay, a number of tools are made from these metals. Okay, electrical wires, when we are talking about, yes, good conductor of electricity, electrical wires are made. Okay, when two or more metals are just combined, forming the alloy more durable in nature. Magnesium is a metal found in the green leaves. Okay, the main component of this chlorophyll. Okay, so these there are a number of uses which we can see from of the metals. Regarding the non-metals, if we are seeing, okay, oxygen we are taking in, it is a non-metal. Okay, if we are talking about iodine used for making tincture of iodine, used in the wounds and all, okay, for that, and carbon, non-metal, Okay, and it is used in number of purposes. And if you talk about nitrogen, you talk about bromine, you talk about fluorine, all the elements, they are having the basic importance, and as a result these metals and non-metals all are very very useful for the mankind as well as for the environment. Okay, so with this we complete this chapter, this metals and non-metals. Hope students you might have understood it. Good day, take care.